Hello and welcome to my channel. In this video, we will learn about merge sort. Merge sort algorithm is an example of a divide and conquer approach to problem solving. A divide and conquer algorithm works by breaking down a problem into smaller and smaller parts until these become simple enough to solve directly. The algorithm repeatedly splits the array into subarrays until each subarray only contains a single item, and then the individual elements which are treated as subarrays are compared one by one, and the process of merging starts to sort the array. This process is repeated until in the final step the two ordered halves are merged together to form a single ordered array. As a result, the entire array gets sorted. So let's understand the divide component of divide and conquer approach. This is the first step of merge sort. Now here in the splitting process, in step 1, we find the middle index of the array. So this is the array that we have and we find the middle index. In step 2, we divide the array from the middle point into left and right arrays. In the third step, we start calling the merge sort function for the first half of the array. This first half will be further divided into sub-arrays until each one of them contains only one element in them. And then in step 4, we call the merge sort function for the second half of the array. Once the merge sort has performed the task of splitting the array into subarrays, the next step is sorting and merging these elements. So here you can see all these subarrays are containing one element, which is the result we have got from the merge sort function. So here in the merging process, we are going to start from step 1. So in step 1, we will be creating two new arrays which will store the values of the left and the right arrays in each one of them. In step 2, we copy the elements of the left and the right array into newly allocated memories that we have created in the above step. In the third step, once the copying process has been done, we iterate on both the arrays till either of them gets exhausted, and we compare the elements of the arrays which will be stored in the sorted order in the original array. In the last step, we are going to transfer the rest of the elements from the array with the larger size to the original array. So you can see in the end, in third step, we got two subarrays where all the elements were sorted, but when they will be merged into the original array, the elements start getting copied from both the arrays in the sorted manner, and thus the original array gets sorted. So in the end, after the merging process, we will have all the elements sorted in ascending or descending order, whatever is required. So here is the C++ code for merge sort function first. So first we are going to implement the divide component. So for this we create a merge sort function that accepts three arguments. The first one is an array accepted as a pointer. Then the left and the right indices from where we will be performing the division task. We then check if the left index is smaller than the right index. This is needed so that we can further divide the array into subarrays. But if this condition evaluates to false, that means there is no need to divide the array. Next, we obtain the midpoint with the help of this formula. We are going to obtain the midpoint only for the array which is having the number of elements greater than 1. Using this midpoint as a reference point, we split the array into two halves. So this call is for the left array, and the second call to the merge sort function is for the right array. And in the end, we call the merge function where we pass the array, the left, the midpoint, and the right index so that we can perform the sorting and the merging process. Once the division has been done, the next step is to implement the conquer approach with the help of this merge function. So step 1 here will be creating duplicate copies of the subarrays which are to be sorted. So with this, I've created a merge function which accepts these arguments: array, the left index, the midpoint that we calculated in the merge sort function, and the right index. Now these two variables, L size and R size, will be holding the size of the array left and array right respectively. To calculate L size, we write mid minus left plus 1, and for calculating R size, the statement that we have written is right minus mid. This variable AL is an array which is going to hold the elements of the left array, and AR will hold the elements of the right array. Now these two separate for loops have been written which will copy the elements of the left array into variable AL, and here we are going to copy the elements of the right array into variable AR. The next step is we are going to maintain the index of the copies that we created in step 1. So here I've created 3 variables where I is holding the index of the left array, j is holding the index of the right array, and k holds the value for the current index for the original array. So here in step 3, we are going to copy the elements from array left and array right in the correct order in the original array. So for this, I have written this while loop where this condition and this condition must be true. So if we reach the end of either of the arrays, the loop will terminate. Once we enter inside the loop, we compare the respective elements of array left and array right. If the element in the left array is smaller than or equal to the element in the right array, we are going to copy the element from array left to the original array at the correct position with the help of this k variable. If this condition becomes false, that means the element in array right is smaller, and then we copy it to the original array. Once this step 3 is over, the next step will get executed when we run out of the elements in either of the arrays, and then we simply copy them to the original array. So if there are few elements left in the left array, then we copy it to the original array by keeping a count of this k variable. And if the elements in the right array are left, then we are going to copy it to the original array. So now let's see how the space complexity of merge sort is calculated. The merge sort algorithm needs extra space for storing the elements in the left and right subarrays. So if the original array has n elements, then these subarrays also need to hold n elements in total, which indicates that the algorithm needs an additional amount of space which is equal to that used by the original array. Therefore, the space complexity of merge sort algorithm is O of n. Let's see the time complexity of this algorithm. So for calculating the time complexity of merge sort, we consider two main operations. First is splitting. That means the division part. In this, we split an original array with n elements until we have n sublist of single elements, and then the next operation is merging. Here we will be merging n subarrays until we have one ordered list of n items. Now the splitting operation repeatedly divides the list in halves. If we take an initial list of n elements and keep dividing by 2, then after log n steps, we will have n sublist of one item. Therefore, the time complexity of splitting is O log n. As the list is divided log n times, where n is the number of items in the list. Now during the merge process, the sublists are combined by examining every item in turn and placing it in the order to a merged list. This means that in the worst case scenario, there will be n comparisons to order all the n items for each merge. Therefore, the splitting and the merging process together involves n log n operations, which means that the time complexity of merge sort in best, average, and the worst case will be O n log n. Here are few advantages of merge sort. In comparison to other sorting algorithms, merge sort has better time complexity, that is O n log n. Algorithms like bubble sort and insertion sort iterate through the array multiple times, which is not the case with merge sort. And finally, the algorithm performs faster and takes less time for large size arrays. About the disadvantages, when it comes to sorting small size array, merge sort tends to deliver slow performance. Apart from the initial input, extra memory is required to store subarrays. And in the end, merge sort goes through the entire algorithm even if the array is sorted, which can surely be avoided in case of bubble sort and insertion sort. Thank you so much for watching this tutorial. If you like the video, please click the like button and subscribe to my channel for more videos on data structures and algorithms. Till then, keep working with smile.